Okay, so now we're ready for method 2. We're going to use the same equation that we had before. Graph the function y is equal to x squared minus 4x plus 1. Okay, the first step is determine if the parabola opens up or down. And to do that, we're going to look at the a value. Now remember, this equation is in standard form, and the standard form equation that represents a quadratic is ax squared plus bx plus c. So we can see that whatever the coefficient is of our squared term, by coefficient I mean just the number in front, number plus the sign. Always include the sign. So the number that's in front of our x squared, that's coefficient. So the coefficient of the x squared term, right, is what we look at to determine if it opens up or down, and that's a. So if a is greater than 0, it's gonna open up, so it's gonna be u-shaped, right? If a is less than 0, it's gonna open down, so it's gonna be hump-shaped. All right, so in this case, in this equation, which is in standard form, we have a here is equal to 1. A is equal to 1. So, and 1 we know is greater than 0. So I'm gonna write in pencil so you can see what the answers are. So this tells me that my parabola needs to look something like that. So bear that in mind, okay? So now we need to find the x value of the vertex. And remember, the vertex is the minimum, and in this case it's minimum because it's opening up. It's just like that point at which the graph changes. So here you can see the line is going downwards, and then here it changes and starts going up. All right, if it were hump shaped, it would be, and in this case it's a minimum point. In the hump shaped graph where a is less than 0, remember what a is, it's actually, the graph is going up, 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 and then it changes at this point and starts going down. Okay, so to do that, it's actually a simple computation where you do negative b divided by 2a. Remember, b comes from the standard form, which is why it's very important for your graph to be in standard form. And by standard form, you cannot have anything on this side. It has to be equal to 0, right? Everything has to be on this side, and you have to have x squared minus, it has to be in this form where you have 3 terms. You have an x squared term, a term that's x to the 1, and then this is the constant, or x to the 0. All right, okay, so let's compute this. So we know that the x value is going to be equal to, put a little v down here so you know it's not this x that I'm talking about. X of vertex is equal to negative b divided by 2a, right? And we know in this case a is equal to 1 and b is equal to negative 4. Remember, b is the coefficient, the number in front of the x term with the sign. Don't forget the signs, guys. So it's equal to negative 4, because this b in the original equation is a negative, and my actual, okay, let me start again, that's confusing. The b from my formula is a minus b. This is my formula for vertex point. That's a minus b. And the b from my equation is a negative 4. So it means that I'm actually having negative 4. All right? 2 negative signs, so minus 4. And that's 2 over 1. All right? So that's actually going to end up being a positive 4 divided by 2, which is equal to 2. So my vertex is going to be at a 2. Now let's find the y value. And to find the y value of that, we're going to use what's known as substitution. Okay, sorry for the horrible penmanship. But you have these steps in your document, which has your notes in it, okay? Feel free to write them out in your notebook, because by writing it, then it becomes, imprinted in your brains. So substitution means that I know what x is, so I'm going to plug that in to find y. Let me pause this. Okay, so we were saying substitution. So This is our original equation. Oh, and I hate working in this tiny space. No, I can't work in this tiny space. And you should never work in a small space. So let's move over to here. I'll just write out the values from our first step. So 1, we know it's opening up. 2, we know the x value of the vertex is 2, what we worked out. So when you have those little worksheets that I give you and they have a tiny space, don't work on the worksheet because it just gets you confused. Do it on a separate sheet of paper. Alright, so that's the x value of the vertex. So now we're going to find the y value. And we're going to do that by substitution. Substitution. Okay, good. Alright, English teachers are happy, math teachers are happy. Alright, so y is equal to x squared minus 4x plus 1. That's my original equation. Yes, okay. And I'm going to substitute the 2 into here and find what y is. So 2 squared minus 4, that's a 2 plus 1. So 2 squared is 4, minus 4, 2 is 8, plus 1. Okay, so 4 minus 8 is negative 4, plus 1, and that's going to be negative 3. So we know that our vertex is actually going to be 2, negative 3. And I've written 2. Why do you think I've written 2, negative 3 instead of negative 3? 2. Pause so you can answer. Yes, I've written 2, negative 3 because the x value in an ordered pair goes there and the y value in an ordered pair goes on the right. So x on the left, y on the right, and remember we said the x value was 2 and this is the y value that we just calculated. So we know our vertex is 2, negative 3. Let's compare that to what we got before. And as you can see, this is where the graph has, this is the minimum point of the graph. So it was descending, 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 came to a minimum point, and now it starts increasing again. So we're kind of on the right track, you know. Okay, so here we're gonna move on to step 4, as we've done 1, 2, 3. 1 was to determine the shape of the graph, whether it opens up or down. 2 was to find the x value of the vertex. 3 was to find the y value of the vertex. And step 4 now is going to be plot the vertex and sketch the axis of symmetry. Alright, now I'm gonna do that here, and look what I have. I've got a ruler this time. So I'm actually going to set the video down so that I can draw. Okay, so here we have this beautiful, beautiful coordinate plane, and it's beautiful because the scale, it has a nice consistent scale. You can see the points are 1 centimeter apart on the x-axis. They're also 1 centimeter apart on the y-axis. All right. Okay, so now we're ready to plot, and we are going to plot our vertex, which we know is at 2 for the x and negative 3 for the y. So a positive 2, that's over here on the right, and then negative 3 is actually down here. Alright, so that's about there, and we know that this opens upwards, so we know it's gonna come something like this. Alright, now step 4 says to plot the vertex and sketch the axis of symmetry. All right, so we're going to get that axis of symmetry, and I can see that I haven't plotted this properly, so let me erase this and make sure it lines up nicely with the 2. So the 2 is there. I'm actually going to draw it right there. Okay, good. I'll pause and come back when it has been drawn. Okay, so this right here is my axis of symmetry. This dashed line, faint, alright? So I know that my graph is gonna be somewhere here, right? Okay. Find two additional points. So the first point, I'm gonna choose an x value either greater than or less than the vertex and then substitute. So I'm gonna choose a value at random. So I'm gonna choose either greater than the vertex. So my vertex is at 2, 3, 4, right? Or less than the vertex. So 1, 0, -1. All right. Okay, so I'll choose 4. All right. So I've chosen 4. So step 5, I'm choosing 4. Alright, and then I'm going to plug that into my equation. X squared minus 4x plus 1. So 4 squared minus 4 times 4 plus 1. So 16 minus 16 plus 1. So the answer is 1. So my point now is x is equal to 4, y is equal to 1, or 4, 1. And I can plot that. 4, and here is the 1. Alright, then to get my second point, I'm going to use the axis of symmetry, right? So here is the axis of symmetry, and I'm going to use distance. So I know that it's symmetrical. So whatever distance this point, the graph is symmetrical. So whatever distance this point is away from the axis, there's another point, another corresponding point that's the same distance on the left side. This is the right, on the left side, away from the axis, okay? So I'm gonna use the scale. So it's 1, 2 units away. So my next point is 1, 2 units away. And it has to be right at the 1, right there. Okay, and so I have step 4 and step 5 now. Well, that was step 5, sorry. I have step 6 now, and that's to sketch the graph. And there's my graph. Alright, let's compare it to the other one. So that's the finished product using the 3 points, the 6 steps. And there's the other one using the 3 points, using 5 points. Well, we ended up with 8 points actually. Alright. It's hard to compare them because the scales are different, but if you look at the key points, so 2, -3, 4, 1, and then it's crossing here again at the 1. So 2, -3, crossing at the 1 here, okay? Alright, and if we were to draw a line right through here, we would, which is the axis of symmetry, you can kind of see, I'll use the ruler or the pencil. You can kind of see that it is symmetrical. Okay, so these are 2 very good methods of graphing equations.